Alright guys, welcome back. We're going to go ahead and finish up page 19, but before we start, I want to make sure that it is very, very, very clear that these four theorems, okay, these four theorems work for any triangle type. I know your books are stapled together, I'm sorry. But these four theorems, these work for any type of triangle. It doesn't matter. Obtuse, right, acute, isosceles, equilateral, doesn't make a difference. Now, the one on the bottom, hypotenuse leg, that's only going to work for right triangles, and we should be able to determine that just based on how it's named. So this one is for right triangles only. Hypotenuse leg, only for right triangles, because those are the only triangles that have hypotenuse. So in a right triangle for hypotenuse leg, the hypotenuse leg theorem says if a hypotenuse and a leg of one right triangle is congruent to the hypotenuse and leg of another right triangle, then they are the same. So let's go ahead and label. The hypotenuse we should know is across the 90. So we'll make BD and EG. So segment BD is congruent to segment EG. That represents the hypotenuse portion. This is also referred to as HL. So hypotenuse, that's H. Then it doesn't matter which leg you go to, so I'm going to go ahead and go just to DC. So they get 2. So segment DC is congruent to segment GF, and that is our leg portion. This can also be referred to as angle side side, but that's not really a thing. It only actually exists in right triangles. That's why we refer to it as hypotenuse leg, because we don't want you writing any dirty abbreviations on your paper. So we're not going to use angle side side. This is referred to as hypotenuse leg. Now, just because if you have a right triangle in your problem doesn't mean that you have to use hypotenuse leg. It just becomes an option for you to be possible if the triangle is right. So, therefore, triangle BCD is congruent to triangle EFG by HL. All right, so let's go ahead and talk through the theorems that don't work. The theorems that don't work here, we've got angle, side, side, and angle, angle, angle. Most of us think, okay, well, side, side, side's a theorem, so angle, angle, angle must be a theorem, or angle, side, side must be a theorem. So for angle, side, side, the reason that it doesn't work, okay, the reason that angle, side, side does not work is because you have to have a restricted angle over here. And I actually have a little video saved on my phone that I want to try to show you. We'll see how this goes. Okay, so here is your angle, your side, and your side. Now watch how this is going to move. Notice how when it moves over to here, angle B has changed value. So there's actually two triangles here. There's this triangle here, and this larger triangle here. Watch again. Notice how this segment is moving. It's the same measurement, but angle B has changed. So angle side side cannot be a thing. Again, the segment moves, creating a larger angle B. That doesn't work. It's not going to actually make a congruent triangle. So angle side side doesn't work because you need to restrict another angle. So it's not going to work because it's actually going to change the angle measure. So as this swings, kind of like in that video, it's drawn a different way, but as it swings, it doesn't work. It's not restricting it. Now, angle, angle, angle doesn't work because even though my angles are 60, 60, 60, 60, 60, 60. These measurements aren't all the same. I can have 8, 8, and 8. or 7, 7, and 7 as my side measurements. Meaning, I can have my triangle angles. Let's see if I can. Probably should have prepped this a little earlier. It's okay. We're just going to wing it, just like in the classroom. Get these little pieces out. All right. So, build our angles here. Okay. So, envision all of these as being like little 60-degree angles. Get one more out here. All right, so we've got our triangle, kind of. All right, pretend they're all 60. If I shift all of these out, notice how I'm not changing the angle measure at all. The angle measures are staying the same. But if I'm proving triangles are congruent by angle, 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 I have to have some kind of restriction on the sides. Because I could extend these sides out as big as I want, indefinitely, basically. And the angles haven't changed. So I have to actually restrict some of the side measurements because angle, angle, angle doesn't. Just because all my angles are the same doesn't mean my side lengths are always consistent. Okay? All right, so angle, angle, angle doesn't work because you need, because you need to restrict another side. Like you have to have side restrictions here, or else you could have a huge triangle and a small triangle. They'd have the same angle measures, but they would not actually be congruent to each other. All right, so let's hop on over to page 20. We've done very well so far, kind of just working through all of the theorems. Well, I hope we've done well. If you have questions, please let me know. But remember, there's 4 theorems that work for any triangle and 1 that only works for right triangles. If it's a right triangle, you have all of these options. It works for any type. But if it's not a right triangle, you're restricted to these 4. All right, let's look at page 20. Let's do some basic problems, and we're going to write a congruency statement for each of these shapes. This is basically what your homework is about for your spring break homework that I gave you on homework number 8. So I will attach that again so you can see it again. So let's determine how the triangles are congruent, write the congruency statement for each. So the way that you want to go ahead and do this is first you want to analyze the type of triangle. So I'm looking here, I see 90-degree angles. I have a hypotenuse, and it matches this hypotenuse. I have a leg and a leg. So these are congruent by HL. Hypotenuse, leg. My statement, I'm just going to write a congruency statement. Triangle JRP is congruent to triangle, so JRP NQX. There you go. There's the first one. HL theorem. Now, HL theorem is not always a theorem that we use. It's only available for right triangles. So let's try the next one. All we're going to do is label. One curve, it gets an A. Those are angles. All right. I see bars. Those represent sides. Double curves. Those are angles. To help me figure out what congruency statement I use, I can fill in my picture, angle, side, angle, or if you're labeling it and it's not becoming immediately clear, I would recommend just writing down your formulas. So you can have side, 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 angle, side, angle, side, angle, 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 side, or not congruent. Remember, not congruent is always an answer choice. If they are congruent, then it's going to be fine, but you don't have to have every single triangle in an example congruent. All right, so let's go ahead and look at our picture. Just drop the cap to my soda. Okay, here we go. The way that you want to analyze these is by looking at one triangle at a time. So I'm going to cover this one up. I count 2 A's and 1 S. So 2 A's and 1 S. This is all sides. Can't do that one. Side, angle, side. only one A. Now it's between angle, side, angle, 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 side, or not congruent. Then, to narrow it down between these two, you have to look at the location of the side. Well, the location of the side is between two A's, which makes it angle, side, angle. The side is between the angles. Side between angles. All right, so this is by ASA, which we just wrote. So triangle BCD is congruent to, because I don't want to go into the other space. Triangle, so BCD, we went one curve, two curve, no curve. FEG. All right, let's try the next one. Again, it's going to be easiest if you write down all your choices. So side, 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 angle, side, angle, side, angle, 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 side. And then obviously not congruent is there, but we're just not going to write it down. All you're going to do is label. So bars get S's. S, S, and S, 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 S. Well, if I'm looking at this, I see no angles at all. So all three of these are out. So side, side, side. If you have no angles, it's got to be side, side, side. So let's try it out. So side, side, side. Triangle HIJ is congruent to. So HIJ, I went 1 bar, 2 bar, 3. 1, 2, 3. Triangle MLK. You've got this. You can do it. All it takes is labeling. Once you get into the swing of labeling and making sure everything's organized, this is going to be a lot easier for you. All we're doing here is just proving that the triangles are congruent. All right, let's try number 4. Again, we label first. Labeling is half of the battle. Curves get A's. Curve bar gets S's. Curve A, S. Now you write your methods. So I'll write them off to this side so we have more space. So side, 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 angle, side, angle, side, angle, 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 side. It might help if you're doing this in pencil. If you don't want to rewrite this over and over again, write this part in pen and just use like your pencil to cross it out, and then every problem you can erase it and it'll still be there. So you don't have to write it every time. That's just a little trick if you want to save some time. Okay, so now we're going to focus one triangle at a time. It makes it easier this way to label correctly. So I'm going to cover this one up. I have 1 S and 2 A's. Well, side, side, side has 3 S's. Side, angle, side has 1 S. So now it's narrowed between these two. Now all I have to do is analyze where the location of the side is. Well, the side is not between the angles. So it can't be angle, side, angle, and it must be angle, angle, side. So narrow it down. Use your tricks and tips to help make this easier, because it's kind of complicated. This is new stuff. We're using letters and abbreviations, and it makes it easier if you just pause for a second, label the picture, write S's and A's, write out your possibilities, and then eliminate your answer choices as we go. When we get into the trigonometry chapter, which will be chapter 4, which we will start after spring break, labeling all of your options and crossing things out is going to help you understand trig a lot better. So what we want to do is build good habits early. So let's finish this problem up. So triangle NOP is congruent to triangle. So I went 1, 2, none. 1, 2, none. QRS. In the next video, we will talk about tricks to help us with problems that look like these. Now, these problems are not any more complicated than what you've just learned. It's just now the triangles are touching. And if the triangles are touching or share sides and angles, there's a few tricks that you have to use to figure those out. But we can do it. All right, I'll see you guys in the next video. I probably should stop it.